Hello dear, how are you? We have to solve a simple problem about the maximum and minimum value of the function. The problem is this: a piece of wire 16 centimeter long is cut into two pieces. One piece is 8x centimeter long and is bent to form a rectangle having side 3x by x. The other piece is bent to form a square of side y centimeter. Show that combined area of rectangle and square is 7x square minus 16x plus 16, and find the minimum value of this area. We have a simple problem. We have a piece of wire having its length 16 centimeter. We cut into two pieces. One piece having length, it is given 8x centimeter, while the length of other piece is not given. We know that length of other piece will be total length minus piece of length of one piece, which is length of other piece will be 16 minus 8x. We know bent one piece of wire to form a rectangle having length 3x by x. I mean to say having length 3x and width x. And by the other piece of wire we want to make a square of length of side y centimeter. We will try to explain it with the help of figure. We have a piece of wire. We cut into two pieces, one having length 8x centimeter, while the length of other piece will be 16 minus 8x. We bent one piece of wire to form a rectangle having length 3x by x, and with the other piece of wire we want to make a square of side y centimeter. First we draw the figure of rectangle having length 3x by x. It is a rectangle which is formed by the one piece of wire. Its length given at 3x, while its width x, and with other piece of wire we want to make a square having one side y centimeter. We have to minimize the area of both these figures, area of rectangle and area of square. We know that area of rectangle, which is side, which is length multiplied width, but the area of square, which is side multiplied side. We here write the formula of area of rectangle. Area of rectangle, which is length multiplied width. Length, which is 3x, multiplied width, which is x. Its area will be 3x square. Area of rectangle we have find, which is 3x square. But to find the area of square, to form a square we have total length of wire, which is 16 minus 8x. With this length of wire, we have to make a scale. We have to make a scale with this length of wire. We start from here to form a scale. This length plus this length plus this length, total length makes us 16 minus 8x. I mean to say that perimeter of scale will be equal to this length of wire. Perimeter of scale will be equal to total length of wire. This 16 minus 8x. Perimeter of wire, perimeter of scale is equal to length of other piece of wire, which is 16 minus 8x. You know that perimeter of scale will be equal to 4 multiply one side. We know that perimeter of scale 4 multiply one side of scale, which is y. 4y is equal to 16 minus 8x, and we get y is equal to 16 minus 8x by 4. We get y is equal to 4 minus 2x. We now write the expression for the area of both figure. Let capital A be the area of rectangle plus area of scale. Capital A denote the combined area of rectangle plus area of scale, which is equal to capital area of rectangle plus area of scale. Area of scale. Area of rectangle, which is 3x square, plus area of scale, side multiplied side. Area of scale, side multiplied side, which is y multiplied y scale, y scale. But we have calculated y is equal to 4 minus 2x. Capital A will be equal to 3x square plus 4 minus 2x whole square. After expanding the scale, we get 3x square plus 4x square minus 16x plus 16. We get capital A is equal to 7x square minus 16x and plus 16. We now have to minimize this area. To minimize this area, we find its first order derivative and equate it to 0 to find the turning points. We differentiate this relation with respect to x. We get dA by dx by dx 14x minus 16. Put dA by dx is equal to 0, implies that 14x minus 16 is equal to 0. We get 14x is equal to 16 and x is equal to 16 by 14 means x is equal to 8 by 7. We will check the value of x, whether it is maximum or minimum. To check its nature, we have to find second order derivative of a, d2a by dx scale, which is only 14. We now put the value of x in this second order derivative. d2a by dx square at x is equal to 8 by 7 which is 14 which is greater than 0. We can say that x is equal to 8 by 7 is a minimum point and it will give minimum area of both rectangle and square. This implies that x equal to 8 by 7 is a minimum point. We write here x is equal to 8 by 7. This implies that because second value of second order derivative at x equal to 8 by 7 greater than 0, its sign is positive. You can say that x is equal to 8 by 7. 8 by 7 is a minimum point. Minimum point, and it will give minimum area. It will give minimum area. And minimum area is obtained by putting the value of x in this relation. Minimum area. Minimum area is equal to, we put the value of x in this equation, capital A, minimum area is equal to 3 p, value of x which is 8 by 7, 8 by 7, sorry, we put the value of x in this equation, 7, 8 by 7 x square minus 16, 8 by 7 and plus 16. After simplifying, we get 7 multiply 64 by 49 minus 128 by 7 plus 16. After simplification, we get 7 7 are 49, 64 by 7 minus 128 by 7 plus 16 by taking 7 as LCM. 64 minus 128 plus 16 7s are 1 1 12. By adding, we get 48 16 64 minus 28, we get minus 64, and subtracting minus 64 from 112, we get 48 by 7. This will be the minimum area. Minimum area when x is equal to 8 by 7. Minimum area of both figures when x is equal to 8 by 7 will be 48 by 7. Thank you.